I'd like to convince you that work done by gravity or change in gravitational potential energy is path independent. And to do so, I'm going to roll 4 different marbles, actually not different marbles, they're all of the same mass, all of the same radius, on 4 different tracks. So one track, it has a very slight downward slope, and then toward the end of its path, increases the slope, rapidly moves downhill, and the ball's going to project off the end of the track and go flying through the air. On the next track, the marble finds a steeper slope earlier in its path. On the next one, the slope is pretty much continuous from beginning to end, and the very last track, the slope starts out really steep at the beginning, has some curvature to it, and in every case, the one thing that's the same is the height of the starting point. Okay. So it's a very different path in each case, but the change in vertical displacement is the same regardless. If the work done by gravity is the same in every case, and there's very little friction, normal force never does any amount of work, the work done by gravity is therefore the net amount of work that's done on the marbles. And we know from the work kinetic energy theorem then that the change in kinetic energy is equal to the work done by gravity. So if we find that every ball has the same kinetic energy as it projects off the track, then that must mean it had the same net amount of work done, or the same amount of work done by gravity. So that'll be the evidence. If every ball has the same amount of kinetic energy, then the work done by gravity must be the same in every case, even though the paths are different. Okay, so to determine whether or not the balls have the same amount of kinetic energy, here's what we need to do. Find where on the floor these marbles hit the ground. The distance away from the edge of the table that they strike the ground should only be a function of how fast they project off, right? Remember, they'll all spend the same amount of time in the air because they're all falling from a desk that's at a particular height. Vertical and horizontal motion are indeed independent of one another, so the range of the projectile is only a function of the speed. So let's check this out. Just to give you a preview of things, I'll put all 4 marbles here, and then let go all at once. Now, the question isn't which one gets to the edge of the desk first. That's a very different question than asking what is the speed of each marble when it does reach the edge of the desk. So whichever one starts out with the greatest acceleration initially in its motion is going to reach the bottom of the track first. The question isn't which one wins the race to the bottom of the track, it's which one is going the fastest when it does leave the track. So I'm going to put this pan on the ground, and we're going to see the marbles hit this pan. Now let me get a sense of where I should put that by just releasing one of these. Okay, I see. One, 2, 3, 4. It should appear that they all hit the ground at the same horizontal range, which means they all had the same speed when they happen to project off the edge of the desk, which means they all have the same amount of kinetic energy when they're here, which means they all must have had the same amount of work done by gravity as they fell from point A to point B, which means work done by gravity is path independent.